Excuse me, this is the operator. I would like to inform all participants the conference is being recorded. If you have any objections, please disconnect at this time. Thank you.
Hello, everybody. I want to thank you all for taking time out of your schedules to listen and I suppose watch in on this. This is Bob Dovis speaking here at the National Soil Survey Center. I guess up here we have Mike Robotham and a few other folks in the crowd here, so don't say anything nasty. And I want to say, if you have questions or comments as I'm talking along, please let me know. I don't get too bent out of shape about that. What I want to talk to you about today is the update of the National Commodity Crop Productivity Index, which is something I've been working with for a while, and just trying to get a way of doing a productivity index, and we'll talk about the whys and everything here. Here's the outline of what I want to talk about today. Talk a little bit on the background, why. I always like to ask why you want to do this. What is it? How does it work? And I don't know if some of you have probably seen it before, sort of some of the data. So I'll just kind of let you know what's different. I'm going to go out on a limb a little bit and talk about how good is it, and talk just very briefly about what we want to do. And I'll clue you in now, we'd like to get this onto the Data Mart. And there's a variety of reasons why it hasn't been done so yet, but without further talk, we're going to get in on the background of NC CPI. The reason why we wanted to do this is because we need to be able to array the soils nationwide on the basis of the inherent productivity. A lot of states like Iowa, a few others have their own state crop productivity indices, and in those states they work very well, and we're not trying to replace those. But most of them, I'm not sure all, but I'm pretty sure probably all, once you get them outside of their area, they kind of fall apart. And NC CPI is designed, hopefully, to not do that. And currently, this current edition is just for dry land agriculture. I've been working on an irrigated version, and it's coming along. We'll be hearing more about it probably pretty soon. And so, some of the theory of this thing is we want to use the use invariant soil properties, because that's basically what the NASA's database is made up of, is use invariant soil properties. And those are hoped, at least, or thought to be a major factor in production of a crop. Of course, you have fertility and other management concerns, but if you hold those constant, then perhaps the use invariant properties of a soil have an impact on the productivity of that soil, the ease of management of the soil, and just the bottom line. You might be able to get as much yield out of one soil as another, but if you're using twice as much fertilizer or something like that, then the bottom line is different. And this is kind of aimed at the bottom line as well. Another operating theory is that the crop is grown on a soil, on a landscape, then it's subject to a climate. So you can have a beautiful deep lush soil, but if it never gets any rain, and you don't have any dry land production off of it. And the same thing goes, you can have a beautiful deep lush soil, fine silty, but if the mean annual soil temperature is 0 Celsius, it's going to be difficult to get any productivity off of it. So the climate, although wasn't really something I wanted to put into the model, it becomes very important because you just can't grow a crop without a climate. And then also kind of going down the climate road, NC CPI is a 3-part model, because we want to deal with frigid soils, or crops that are grown on frigid soils, winter wheat, some corn. Crops that are grown on mesic soils, winter wheat, corn, soybeans. in crops that are grown on thermic areas. So that's cotton, really. Although wheat and corn will also grow there, but they're out of their comfort zone, really, in a thermic environment. So the thermic crop that we're after is cotton, which introduces a whole bunch of stuff, but that's something we can't talk about here. Projected users, you don't want to do an interpretation if there's nobody going to use it. And it turns out that there's actually quite a few users and more on the way. Farm Service Agency likes it as part of the rental rate calculation. I've dealt with the Risk Management Agency because they can kind of get an idea of how insurance claims are going, if they're being subjected to fraud, really. The ERS folks have used it to help in projections, and a lot of real estate people like it because you can get an idea of quantitatively, getting a value on Farm A versus Farm B. Other people that have been after me on this are, land assessors. Well, I have that, real estate assessors, but also seed companies have been like NC CPI data, and also quite a few university people, Cornell and Penn State, and actually University of Nebraska also. So it's actually got a pretty a broad user group. So what is this thing? Well, NC CPI is, it's a fuzzy system model that uses the data and relationships that are in the NRCS database. All of the data comes out of NRCS, whether that's good, bad, or indifferent. It does allow us, meaning the soil survey program, to have control over the data. Everything that is in there, if there's something I see is wrong or peculiar, nothing's ever wrong, some things are peculiar. In theory, I can call somebody on the phone and get it changed to be less peculiar, at least in theory. Also, if we have all the data in one place, then if somebody in California runs the model, they get the same thing at the same time as somebody in Florida. And so it has a good consistency. It's been vetted by a lot of people across the country. And so we're really, that's one of the things I like about it, is because we actually control all the data. We don't have to worry about going out and fetching data from outside sources. And for what it is, you have to realize it's an index that is to array soils on the basis of their inherent productivity. We're not really trying to predict the yield, because in order to really predict the yield, at least for a particular year, you need a whole lot more data than what's in our soil survey database. But we have, we can look at soil properties versus, a membership function. Actually, we're asking the question, or answering the question, soil is a member of the set of highly productive soils if it has, an AWC of 30 centimeters per centimeter and so on. And so we have membership functions. Well, in this condition right here, this situation I'm showing, corn yield is the membership function. And we're just looking at available water holding capacity. Nothing major thing there. Actually, it's a major component, but we use the relationships in the database. Some soil, landscape, climate parameters have a bigger impact than others. But some are only, really seem to kick in the extreme, like bulk density doesn't seem to do much until it's just too dense. For cotton, its pH almost is meaningless unless it's about over 8.5 or below 3.5. So, some things are really only important in the extreme. But when they're important, they're really important. They limit the growth of the crop almost entirely. And so in order to construct the model in NRCS, we kind of look at the shape of the curves. You can see this here. You have a definite maximum here at, around just a little under 1 perhaps, or about 1. And this is kind of an interesting variable. You see it's the log of the product of the saturated hydraulic conductivity and the linear extensibility. What's that all about? Well, in order to make something that's going to work around the country, you know, vertisols are an important part of the farming community in Texas. And since we're dealing with saturated hydraulic conductivity, well, a vertisol's saturated hydraulic conductivity is very low. But it has a lot of cracks because the LEP is pretty high. And so what we're really after with this is just the gas transmission. So that's why we have the Ksat times the linear extensibility. And you see, and then the logarithm of it, that just presses it down into a usable framework or a usable piece of real estate on a graph. So you see a lot of interesting relationships in just this one graph. You know, you have a definite maximum here, a rising limb, and a pretty abrupt falling limb as soils become faster and faster in their permeability. And so just relationships that are in the database. Some things aren't independent of one another, which always makes it interesting because rainfall and mean annual air temperature and mean annual precipitation in the domain of corn walk hand in hand. And so, but what is really limiting to corn growth is probably not the rainfall so much as the temperature. And so there's just, you know, lots of relationships, lots of interdependencies. And so one of the things I want to look at is just the shape of the curve. And that's part of the problem with this also is, or one of the opportunities is using the data, the yield data that's in the database. Well, the whole reason for having the index is because the yield data is flaky. And so here we are with the yield data coming up in the development of the model. But really just looking at trends and where things are peaked out or where they're minimum. And so we're looking at arraying or comparing soil properties to productivity. And we look at that enough, then we can finally decide to put that into as a fuzzy set or an evaluation in the NRCS database. So you see there's our nice curve here, peak around 1. So we translate that into an evaluation, and a peak around 1, gently rising and steeply falling after the maximum. So we capture those relationships and those trends in the data, trends in the relationship, really. I don't have any R-square stuff on here, but just this little thing here, this spline function has an R-square of like 10%. So my yield production, 10% of the variation is just based on Ksat times the LEP from 50 to 100 centimeters. So that's kind of interesting. What sort of data does it use? And NC CPI uses quite a bit of data in the database. One of the biggest things is the root zone available water holding capacity. We also look at the bulk density because that's one of those things that most of the time isn't a big player, but in the extreme it's important. Saturated hydraulic conductivity is like that also to an extent. Linear extensibility is kind of interesting because that's a two-tailed curve. If LEP can be too low for high productivity, and it can be too high. So it's a, you know, kind of like not necessarily a bell shape, but it's got two tails. Rock fragment content, rooting depth. Rooting depth has been pretty disappointing. The data there is pretty flaky. I don't know quite why. We look at the sand, silt, and clay percentages for physical data. Chemical data, we look at the CEC, pH, organic matter content, SAR, gypsum, electrical conductivity. Climate data, or landscape data, slope grading and shape are important. Ponding, flooding, water table, erosion, surface stones, rock outcrop, and other phase features like channel, whatever that means. You know, it's used in some places around the country, but not everywhere. But it seems in some places it's a correlation thing. In some places it's very important. In other places it's not recognized the same way. So that's been kind of a challenge. climate data that the model uses, mean annual precip, mean annual air, frost-free days, MLRA, and the soil temperature regime. MLRA is kind of a peculiar thing because for winter wheat, the best area for winter wheat is in a xeric climate. And so I needed to be able to capture the areas where it's a xeric climate. Well, sometimes that shows up in the soil taxonomy name. Other places, other times it doesn't. But it's usually more or less constant within an MLRA. So I picked up the xeric nature using just a lookup table of major land resource areas. Kind of clunky, but seems to work. So how does it work? Well, NC CPI looks an awful lot like the story index. The fuzzy numbers or the scores for property they're multiplied together. One good thing, I think, is that one low property score can drag down the whole score. So if you have a really high or really low pH with everything else being just fine, the pH is what's going to drive the bus or drive the score or the overall index. Uses a lot of hedges in the fuzzy system to modify the fuzzy numbers. And it's three factors: corn and soybeans, winter wheat, or small grains, and cotton. So the highest of those three is taken as the score for a component, but most of the time for scientific analyses, really one score or the other is more informative than the overall score. Although for programs, then I think the overall score is probably more useful. Ooh, that's a pretty busy looking graphic, but that's the corn and soybeans model. And you can see there's a lot of different things going on. Chemical properties, water holding capacity is broken out. Their water supplying subrule is its own subrule. It's a major part of productivity. Climate, landscape, interpretable component just is a switch to be able to not let certain components like produce an index. I don't know. Sometimes taxon above family are seem to be farmed, and other places not. So, but miscellaneous areas usually not. Some taxon above family aren't too. Physical properties. One of the new things here that I did for version 2 is I used to just add or subtract the crisp positives and the crisp negatives. And the reason why these are crisp is because there's not a really good way of making a spline function, erosion, or some of these other things. And so they're more of a Boolean. It's either channeled or it's not channeled. And so using the not hedge is what's 1 minus the fuzzy number. So if there's 0 crisp negative attributes, and 1 minus 0, well, that's just 1. So the product of 1 times any other number is just the number you started out with. So that's how that's actually made quite a difference. Rather than just adding or subtracting it from the score, it's multiplied to the inverse of it, not the inverse, but well, it's kind of the inverse, but not in this way of thinking. It's just multiplied by the overall score. And this is just a graphic that shows the overall model is just the 3 pieces: corn, soybeans, small grains, cotton. The OR operator means that we take the highest of the 3. And if you can come up with a better way of doing that, let me know. You can't really, you don't want to use the lowest because over most of the country, cotton comes out as a big fat 0 because cotton's got to be thermic or it doesn't grow. Weighted average, maybe a weighted average of the 2 that are 3 that are relevant, I don't know, but right now I just use the highest one. So what's different between version 1 and version 2? I borrowed this thing called sufficiency from Missouri. That's kind of an interesting concept, and basically what sufficiency does is prorates a data element, say available water holding capacity, with depth, under the assumption that water close to the surface in a soil is more valuable to a crop than water at some depth, like 150 or 200 centimeters. And so it kind of prorates the value of that property with depth. But available water holding capacity is the one that really came out. It was like a 5% difference in the R square between just a flat root zone available water holding capacity, like I've always used it, and using the root zone sufficiency, particularly for corn, and less for small grains and a little bit less for cotton, because there's simply some of these crops don't require the water that corn does. And I've mentioned that the score from negative soil attributes is handled differently now. I've done some different things with the way seasonal soil wetness, particularly in cotton, because it's a really long growing season. pH and lineage sensitivity are stratified by the median precipitation. It's kind of interesting. This mostly happens in cotton. Cotton is really is a very adapted and adaptable crop, ranging from 2,000 millimeters of rain down to about 500 millimeters of rain. So it covers so much territory that the genetics of it have got to be different from place to place, and its response to pH is different. Although we just call it cotton, so we don't have any differentiation there. Cotton. Some cotton apparently can handle a low pH, and other cotton handles a high pH. It's not the same cotton plant as others. So there's a few of the different things that are different. I think there's probably a few others, but those are the big ones.
Bob, you're breaking up.
Well, that's not me, son. I don't know what's going on here. Somebody's got, I don't think they put this thing properly. I don't think it. So, how good is it? Well, that's a good question. That's a bad answer. So we have three different lines on here. The orange line is just a linear fit. This is my idealized thing because I wanted more or less a linear relationship between the cotton index and the yield, or the corn, or whichever index in the yield. Excuse me. And so that's the orange line. I guess that's orange. The red line is a smoothing spline that's, and so it's basically a linear regression using least squares. The green line, or the teal line, is an orthogonal fit. And that's all pretty esoteric. And there might be somebody in the crowd that can understand this, but the reason for that difference is that linear regression assumes that there's no variation in X, which means you've measured X without any variance. If you say it's 1, it's 1. If you say it's 2, it's 2. But we know with the soil data, we're looking at estimates of estimates, so we have a lot of variance in there. And so linear regression, if you're using soil properties out of NASA's linear regressions, you're violating the rules there. And that's why you see the red line doesn't seem to follow the axis of the points, because there's too much the variance isn't accounted for with linear regression. When you're fitting X, or fitting Y to X. So the green line, does this sound about right, Clayton? The green line here, the teal line, we're fitting X to Y. And so we're looking at more the index being the dependent variable and the yield being the independent variable. And so it has a slightly different look. So I figure if I look at the volume of points within this, then that's, we're showing, that we're doing a pretty good job of holding down the variance. But you see there's a lot of points all over the place. And sometimes when I get really bored, I start pecking out what's going on. Why is this point out here in left field? What's going on there? Is that a breakdown in the model? Am I missing something important? Or is it a fat finger error? Or just what's going on there? And so we come up with a poster child for data harmonization. So when we look, well, this one point's way out in the left field here because it's actually frequently flooded. And we don't usually have, better productivity on something that floods every month of the year. And so this 900 bushels per acre or pounds per acre is probably a little optimistic for that particular soil. So we go over to the next ones over here, and we see that they had 165 frost-free days. I can't remember which component it is, so it probably wouldn't be good to say anyways. But cotton's entry level to even be able to get a crop is around 180 frost-free days. It likes to have at least 200. And so we probably had a map unit that was dragged, pulled, correlated from a northerner's place down to a southerner place. The yield was touched, but the frost-free days weren't. The frost-free day value wasn't changed. And so there's a kind of a harmonization or a data checking issue. So we'll look at a couple more of these things, because I really got going on this, because I was wondering, why is the R-square, when everything looks so good in the model, why is the R-square less than 0.5 with this data, with the yield data? And so I think, well, sometimes the yield data needs to be updated. Here's a soil, Sasser. Some of the older surveys, 300 pounds per acre. This is cotton again. Some of the newer surveys, around 900. So that's the up and down variation. You see up and down the yield scale variation. The left to right variation is a little more, can be a little more problematic. So what's the left and right variation? Well, sometimes, if you add slope, the soil slope is increasing, then you would expect the index to go down with slope, and that would be okay. Sometimes soils are eroded, and we'll see one of those. Sometimes it's, the yield data is also not just vintages, but also the states have different conventions of how they want to have yield populated, or how they even think of the yield. For instance, if you have the Tama soil in Iowa, then they're looking like 220 bushels per acre as the populated yield for Tama. So you step across that line into Illinois, and you drop down to about 180 bushels per acre. Same soil, same everything, really. It's just a difference in the conventions of the state. Now, I would not be surprised if the land grant, the extension people, we'd have some influence there, because some places they might advocate a little more fertilizer use than others, or whatever. And so you can have yield differences there, up and down. The vertical difference, this one was pretty amazing, and so I thought I would track it down. And here's what we found out with this one, that the only difference in these components were the frost-free days. When you look at the distribution of the points, you have one out here by itself. It's actually several points. There's about 30 or 40 squares lighted up. But the distribution is the same kind of distribution. That's the only thing that's different between those soils is the frost-free days. And whether that should be or not, I don't know. But certainly the ecologic variations aren't being accounted for at a frost-free day score of 0.26 as opposed to 0.90 something. So that's another data checking issue. And here's a couple more of these. I won't do this too much more. Cecil. Some of you have mapped Cecil. You know what Cecil is. just a nice big blast right in the middle. But so, you know, there's some variation left to right. You'll see soil also has erosion and slope issues and stuff like that, and so you expect some left to right variation. So you have different vintages, different philosophies of data population or yield populations, giving you some of the vertical variation. Same thing over here on Amarillo. Nice big clump. But then someone's trailing up here. I don't know quite exactly what's going on with those. I don't know if those were actually a yield that somebody reported somewhere, or if it's just something peculiar going on. But all these kind of things help to decrease the R-square of the model that actually, I think, captures the salient points, salient features, salient relationships of the soil properties to crop productivity pretty well. And there's UCI. This data is harmonized. The shapes, maximum, minima, and various curves probably have to be reevaluated. Well, either that or we get a lot more of data from independent sources. But then just getting a hold of that data has been difficult. It's out there, but quite a task to get it together. All right. And what's the future of this thing? Well, as I mentioned before, the next step is to get it onto the Data Mart. And that'll give a real chance for some serious vetting. But also, this is kind of a heads up to look at the output of the model, you know, how it's arraying the soils in your area, the soils with which you're familiar, and just say, well, you know, this doesn't look right here. Or it looks pretty good. You know, if it doesn't look right, let me know. And, you know, we can see if there's something missing or what's going on to be able to adjust for that. To learn more about the NC CPI, if you go to the technical references page on soils.usda.gov, down towards the bottom of that page, there's the NC CPI user's guide that you can look at. That's a couple, 3 years old now, but really some things have changed, but the philosophy is still pretty much the same. And I just want to, that does it for me there. I want to say thanks for listening, and if you have any questions, and the caption you can't see of this picture is use no-till or the ag police are going to bust you. This is a police tractor. I've never seen one of those before. Police tractor. So anybody have any questions or comments or anything for me?
Yeah, Bob, quick question. This is Leslie Glover out of Arizona.
Okay, yes.
I noticed with your climate model that you were using thermic for the cotton production. Did you also include hyperthermic?
Yes, sir. Yes, sir.
Okay.
Yeah, thermic and hotter. That also takes in isothermic and hyperthermic, but I don't think it gets isomesic. I think mostly because the isomesic in this country is probably in Hawaii, and I don't think they don't grow cotton in Hawaii. Yeah, and so even though it could possibly grow there, it might not get hot enough, but we're saved by the geographics of it just isn't grown where that temperature regime exists for isomesic.
Hey, Mark, this is Paul Benedict. Also, some of your desert areas are going to have, they may be thermic, but their nights will be too cold for the cotton to grow well.
And I think most of those places are going to be a little bit on the extra dry side too. So I can't remember what the cutoff is. It's like, I want to say 400 or 500 millimeters of rainfall.
Right. Which brings up the issue of irrigated. You know, and I know you've been working on an irrigated index too. What's the status on that one?
Well, I've got that as good as I can get it on my own. I've got my straw man set up again, and it's ready for some pot shots. I suppose we'll get more of that out on that later. But if anybody with some NASA's access can look at it, and I have reports written so you can easily, and for dry land too, there's a lot of reports written on Pangea if you have NRCS. You don't even need skills for these. All you need is access, because I have it down to the point where all you got to do is, you hit the button that says run offline against the national database. And if you can just remember the first 2 letters of your state FIPS, you can put that in with an asterisk and run a variety of reports with just those 2 pieces of data.
That sounds like somebody at headquarters could run that one.
I don't know. I think, though. Yeah. No, actually, yeah. But another thing I wanted to mention on this is to really get some analysis, like you saw in my graphs I have in this. I use JUMP, statistical analysis software. I mean, and that's something we've got to get into pretty much everybody that wants its hands. I wouldn't say everybody needs to have it, but if you have a want for it, we need to get that to people, because it's really neat to be able to see the relationships of soil properties against other soil properties, because when things are, if somebody's a little bit off the reservation, boy, it really shows up in a hurry, because you have a big cluster of points with a couple of outliers, and you think, well, what's going on there? Is that a fat finger thing, or is somebody, freelancing a little too hard, or what's going on there? And you can, being able to see the relationships between properties is pretty good. And they also have, scripts to do that, to pull properties, in groups. And then, and also to map properties, just the soil property output too, with the map unit key, and just put it in make a GIS product with it. All kinds of things, so you can kind of get the idea of how soil properties are affecting land use, or in this particular case, soil productivity. So GIS products, and as well as the statistical analysis software. Because Excel, I don't know, the later versions of Excel get over 300 data points on a graph? I don't think so. With JUMP, you can put in, I had like 200,000 or 300,000 data points in some of those graphs I was showing you.
Bob, this is Kerry Arulis out in the San Joaquin Valley out in California.
Yes.
And yeah, hi. I had a question. Recently, a few of the risk management agency folks have been talking about dry land wheat, and especially in the thermic condition, because that's where a lot of ours is grown out here in the xeric area.
Yeah.
I was just wondering if you'd address that a little bit further, because you mentioned it was out of the comfort zone, and you're probably right.
Well, I think the xeric is probably going to override the thermic, because just having the way wheat is, winter wheat, it's got it's in the ground when the ground is moist, and about the time the water turns off, it's ready to be harvested or close to it. And so it's kind of a really nice fit for a xeric climate. I'm not so sure how the thermic works on that, although we could look at the wheat index and see how that kind of goes. Because
yeah, I think in our case, a lot of them were pushing it down on the low end, maybe below 10 inches of rain, and those areas are getting pretty marginal. And
yeah, that's
the vast majority of things out here, of course, are irrigated. One county with close to $7 billion in ag production, so that kind of thing. But there are those edges where the dry land is grown. So thanks.
Yes, sir. Any other questions out there?
Is your PowerPoint available anywhere?
It can be. Do I make that generally available, Mark, or how do you handle that?
We'll be posting this by tomorrow afternoon.
All righty.
PowerPoint and the recording.
Okay, there's your answer there. I was afraid they were going to videotape this, and in which case I was going to say, no, thanks, Mark.
Where is it posted, Mark?
You'll get that information in the email.
Hey, Mark, I got one more question. With drought being a common thing in the South and Texas this year, have you looked at giving it any kind of confidence, what's the right term, it's accurate 80% of the time, or?
Yeah. I've dealt with that some, thought about it some. As you can tell, we're looking at static kind of data just to get the index. We're not really trying to predict a yield.
Right.
So we get those off of our back. So I think in most cases you're looking, it's probably pretty good plus or minus a half a unit. So if you had a 0.6, that's a 0.55 to a 0.64, somewhere in that ballpark. I have done some experiments where I've changed the rainfall, but like I say, that nothing doesn't everything co-varies. So you don't just decrease the rainfall or increase the rainfall, because when you do those, you're probably also having some mean annual air temperature or frost-free day effects as well. And at least in corn, in the domain of corn, as you increase the temperature, the rainfall also goes up. I don't know if that's always going to be true, but that seems to be kind of hold true with what the climate change people say. They might get more severe storms, but in general the rainfall increases with temperature. And so it gets to be a little bit more of a mental gymnastics exercise to try to think, well, if I'm going to decrease my rainfall, then is the temperature going to go up or down, stay the same, or, so I guess you'd have to put together several scenarios for that. Anything else? Any questions from the peanut gallery here? No? Well, thanks again for listening, and if you have questions on this, please give me a call. If you see something that looks flaky or something you just plain old don't understand, and there's a lot of fine structure we didn't talk about today. And so if you see something, what the heck is he doing here? If you just give me a holler and we'll talk about it.
Bob, this is Cleveland.
Yes, Cleveland.
The irrigated productivity index, are you going to put a bulletin out and request a review by state?
I think so. That's about right, Mike. We'll probably have a bulletin come out.
Yeah, it should be out soon. I think this is Mike Cleveland. Bob says we're darn close to good to go, so we'll get that out the door here pretty quick.
Okay.
Any feedback is much, much appreciated. So.
Yes. But the irrigated thing is, once you start throwing water on, a lot of soil properties, unless they're in the extreme, they just don't make much difference anymore. But still, I think, though, that the management has to be more difficult or more informed as the soil properties become less and less favorable. So I think it still has some value. All right. If there's no more questions, I'll bid you all goodbye and have a good rest of your day. And thanks again.